Hi everyone, I would like to introduce for you the hydraulic component sizing calculator. I have released version 3 probably like a year ago, and I don't have time to upgrade it, but I will consider this in the near future. That kind of software is required to do the hydraulic component sizing calculations for system designers or machine builders. It offers you a very easy and quick way to size your components without getting to the hassle of solving too many equations and all of that. My first advice when you launch this software, after you setting it up, you're going to run this software as administrator in order to get the full feature of this software. So when you launch it for first time, you're going to see a menu here on the left side, and in this menu there are a number of components like what you see in here. And when you click on any one of these components, the relevant page will gonna be in front of you. So let's just start with the first one, which is a fixed displacement pump. So which is a pump with just a constant size, and all what you need to do is to put the input data, and simultaneously the output data will be calculated for you. So the input data here always split into two boxes like what you see here. The first one, you should assign, through the first one you should assign the operating conditions, and in the second one you should assign the design parameters of the pump based on which these output data will be calculated. So for example here, the two operating conditions that we need to assign is the pump driving speed and the pump loading pressure, which is the system pressure in front of the pump. And in case if you need, in case if you see two scroll bars like this, one of them is doing changing the operating condition or whatever we have, and the other one is doing fine tuning. So when you see this is, that gives you up to the third digit type of like fine tuning for every value that you have chosen from the upper one. Pump displacement, here you can also change the pump displacement, and you still have here kind of fine tuning for this pump displacement. And then you're going to have here the mechanical efficiency, volumetric efficiency defined at certain pump speed and certain pump pressure. Based on that, you're going to have the first thing being calculated is the volumetric efficiency. You may say, why we have this volumetric efficiency if we already defined it here? The answer is you already defined it here for under specific operating condition. If your pump is going to run under the same operating conditions, that's fine. So if you have these operating conditions equal this, you're going to see the same volumetric efficiency as has been reported here. Otherwise, the full efficiency will be changing by the operating condition. So if you define this at certain operating conditions and the actual operating conditions under which the pump will going to work, so this will be resulting in new volumetric efficiency calculated for you here. Based on this volumetric efficiency, we also calculate how much flow rate theoretically should be given by the pump and how much actual net flow rate will be given. Then the leakage will going to be always the difference, and then this is the overall efficiency of the pump. And based on the overall efficiency of the pump, we should be able to calculate how much actual output power from the pump and how large is the prime mover. Then we also have here a cell that calculates the this will be the overall losses, and this will be how large the prime mover is. And then the last cell here, we calculate the torque on the pump motor shaft so that you can use it for sizing your coupling. So as you see here, we have the English system of units, and under your finger click, you can just switch between the English system of units and the SI system of units. So everything here switches from PSI to bar, cc per rev to, or cubic inch per rev to cc per rev, gallon per meter to gallon per minute to liter per minute, and then from horsepower to kilowatt, and even this torque is being changing from pound-force inch to or pound-force foot. Here we have pound-force foot, and then this being changed into like Newton meter. The lower part here is kind of a virtual reality, give you better sense, and also these scroll bars are linked to the relevant ones here. So as you were able to change the speed from here, you're gonna see the green label here changing simultaneously, and that scroll bar changing. So you can change here the speed, you can change here the pump size, you can change here the pressure in front of the pump. So that gives you better sense, but it won't change any of these results. When you're done with your calculation, what you should be able to do also is to go here, rather than you like take a screenshot to save these data. I made in the utility here report generator tab, but to get this, I'm on purpose I'm showing you here that you won't be able to generate the report unless you are run this software as administrator. So I will close this, go back here on the other part of my run this as administrator, and get this back to you, and come back here to the fixed displacement pump. Now assume that you made these changes, you made all these kind of changes on your calculation, and now you would like to do to generate a report. When you click report generator, now you see that you have, but providing you should be able to run this as administrator, because he go and seek files from somewhere. You won't be able to do it unless you are administrator on your computer. So you have here the date, report time, and all these data, including also operating conditions, design, and output data. You can save this for use later on. In addition to that, you have also the formula sheet, which is a PDF file. PDF file here, I'm gonna just make it smaller for you, so that I'm gonna show you the all the calculations, all the equations, the reference file, very good reference file for you, in case if you'd like even to do manual calculations or something like this. And also it's helpful to give you meaning for every parameter that I have used in the this is like one tab, which is the fixed displacement pump. Similarly, you will have different other things, but I missed to say that in the utilities you have like an additional unit converter. If you click on this unit converter, you're gonna get another program built in, which will take you to do conversion for units from different systems to other units of different systems. So similarly, you have here a hydraulic motor, and you have double acting cylinder. For each individual extension stroke or retraction stroke, you can do all these calculations. And also for cylinder buckling calculation, we should be able to calculate based on how is the cylinder is being mounted, what is the material from which this cylinder is being made, and based on the safety factor and dimensions of the cylinder, we should be able to calculate what is the maximum allowable compressive load. We have also a good tab for calculating or sizing an accumulator based on the minimum maximum system pressure. We should be able, and how is the accumulator will be charged, isothermally or adiabatic. If it is adiabatic, you should be able to get the adiabatic exponent by clicking on this, so that you can get the adiabatic exponent based on the temperature and the average pressure in the system. And also you should decide what is the size of the accumulator and what is the pump flow rate, and you're going to get all this information about what should be the initial gas pressure, how much energy will be stored in this accumulator, how much time it takes to charge this, what is the power, and what would be the maximum compression ratio for this. And as you see here, we have different types of accumulators: piston type, ladder type, diaphragm type. We should be able. Some cases, when you see this arrow here, this means that you exceed certain critical conditions, or you have an issue with the selections that you have made, so you need to probably change your selection to get rid of this. So, and also the fluid line here. Fluid line is by putting the flow rate, the fluid properties, and the dimensional parameters of this fluid line, you should be able to know whether you have laminar flow, turbulent flow, and in this case you should be able to make changing to your design parameters or operating condition to force the fluid to be laminar, like what you see. In addition to calculating obviously the Reynolds number and friction coefficient and how fast the oil will be passing through the line, and how much pressure losses are going to happen in this fluid line. So I hope this is beneficial for you, and you can always order it from the CompuDraulic website. Thank you. See you later.